Hello, everybody. My name is Ryan Beltran. I am the executive director of MakeWater.org, and this is our third Thursday MakeWater Meetup. I am recording this for anybody that joins, so just know that these will be recorded and shown later, or be available on YouTube. So stop that music. So today we're actually going to be going over our new kits that we're going to be trying out for our middle school, our middle schoolers this year. We got a sponsorship to work with San Antonio middle schoolers through San Antonio Water Systems. And this video will be a great way to just kind of learn real quick about what the kit that we're going to be using is, how the program works, and you could use it as a reference. Anybody that's watching this, you're welcome to reach out to me and we could do it one-on-one. I can just reach out, Ryan at MakeWater.org. Go to our website if you want. I can also we could just set up a time to chat and we can do one-on-one if you want to know more information about how to work on this program with your students and your kids. So today I'm trying something out where I got another camera. I'm going to see if I can spotlight it, where they're just kind of like another person joined in the room. But I'm going to be going over what our new kits this season look like, what they do, what's in them, what we're going to be trying out. These are what we call a coagulator kit. And coagulator is because these run a process called electrocoagulation, which can actually separate some pollutants in water or make them coagulate in the water. And we can go over how they work here in a bit. Let's see, please spotlight. Yeah, so just again, a little bit about MakeWater. We challenge students to be citizen scientists and innovators where they can actually potentially do something to help climate change, to help water issues, to help energy issues. These kits harness the power of water and energy together to purify water. And it's a fun experiment, but it's also done in a way where students can give their feedback, tinker, and make it better and be part of like moving the ball forward and innovating these kits so they can look back and be part of something that has grown. And we love growing organically in that way with students' input, teachers' input. So I'm going to get right to this year's MakeWater kit. We have used a kit in the past that is called an Arduino, and it looks like this. And it's something that you can code. You can put a code on here, and it can loop that code pretty much. I'm gonna wait for this card to pass. And for those, now I got a car like alarm going off. I hope that's not too bad. But for those who don't like to code, we've actually made this plug and play so that it just does the process. So the teachers don't really have to worry that much about the code. But we found this new kit called the Microbit, which makes coding actually really simple and fun. And we have included that in the curriculum this year, the Microbit. So we're trying this out for the first time this year. I highly recommend checking it out. Students of all ages have been able to mess with it and make really amazing gadgets simply. I will actually share my screen of how this actually works with our kit. Or I'll give you a little quick view of the coding side of it because it's kind of fun. Let's see. Here is here we go. So this is the Microbit program that you can download as an app to an iPad. You can run it right from a browser, or you can download it onto a computer. But it's really fun. You can plug and play all these different codes. Like they make it very visual, and I'm a very visual person, so it really stood out to me, this method of potentially using these microcontrollers for our program. I got to actually give it a shout out to Youth Code Jam here in San Antonio. They do a lot of coding educational events, and they recommended trying out the microbit. So we were excited to try it out from their recommendation. Just for like the age range that we're working on, middle school and maybe even lower high school, or people that don't want to do something as intense as maybe like an Arduino, because it requires actual like coding piece by piece, word by word, or line by line, whereas this makes it funner and more visually appealing. Like for instance, this here says to press button A, and it shows you what the board looks like, and it'll actually do what you've coded. I had it say, when you press A, it's going to run power through this pin here, and it's going to play a melody when you start it. So you hit A, and that is going to power on this kit, and it's going to be doing the process of electrocoagulation to the water. And then when you're done, you hit B. I made it do another melody. I just think that's so cool. And this is something that you can just do so many different variables, and I'm really excited to see what sort of things the students bring out of this, because all the potential things you can do with it. There's an LED screen here that can have letters scroll across. It can tell you different readings. So there's a lot of depth, and there's a lot of things that can kind of progress as we work with these kits. So it's early on. We're just at the beginning of trying out these kits. And sometimes when we come into issues, we actually sometimes will bring it up as a challenge for that educator. We have a very baseline curriculum that we're working on, especially with these new TEKs coming out in Texas. These are Texas standards. There's some standards coming out, some changes for middle school, and they're really in favor of like more robotics and coding. So we kind of fit a really good upcoming change for that, for middle schoolers especially. And I thought I would share this today because I think this kind of neat. I never think I don't think you could be too young to learn about computers and engineering. I bought this book for my baby. It's called Computer Engineering for Babies, and it's so cool. It just I couldn't help but get it. It's interactive, and it teaches you some little basics about coding. And as you kind of go through the book and try different things, it teaches you some of the basics. And there's sensors here, and it's just a fun book. I thought I would give it a shout out. That's by Chase Roberts and Baby Step Books. Okay, so we're just gonna do snap circuits. So Jessica in the chat says that the microbits kind of remind her of snap circuits. I don't know much. I don't know much about snap circuits, but I'd like to hear more in the future if you could show me those. There's a lot of cool like kits out there. That's why sometimes they can fly under the radar and you don't know or hear about them. So I'm going to spotlight this other camera. Let's see. Add spotlight. No. Make spotlight. Spotlight. Spotlight for everybody. Okay. So here's the kit. We got a new design for it. We'll just show you what comes in the kit for this season. Has a 3D printed lid, which the students actually help us innovate. That's one of the challenges they can take on. They have helped improve these lids, this is where the electrodes are going to go through, and it rests right on top of here. So students have helped innovate it. We've made it thinner and use less plastic, so it's better for the environment. That's a fun piece. Comes with some alligator clips, so you can run a current through the circuit, or the circuit board, the microbit. Comes with some black powder paint. This is our quote unquote pollutant that we test with. It's tempera paint and a little bit of salt to add conductivity to speed up the process. Here's 2 aluminum electrodes that come with it as well. This is the microbit, just instruction manual that comes with it. Here's the microbit. And it comes in the plastic protective packaging. So pull that out. Some ASMR sounds. So I know it's all backlit, but this is such a cool little board here. And each of these metal pins here is a connector that can send information. And the fat ones are the ones that are made kind of wider so that you can actually clip the alligator clips to them. And I will leave it as a surprise because I kind of want it to be something that all the educators get. But when you first start this, there's a really fun tutorial that you actually are hands-on with this to learn all the different things and sensors that this comes with. So highly recommend once you first get this to just plug it in and follow along. It'll tell you itself how to progress. So it also comes with a little battery pack or battery housing. And it comes with the batteries through AAA. And then it comes with a USB cable so you can connect it to the computer. The actual jar that we do the process in, and the lid. And we try to make sure we use every single piece and component that comes with it. So what's neat is you have a USB cable here if you want to connect it directly to a computer, but this actually has Bluetooth, so you can connect it right to an iPad and upload the program as you work it out. So that is everything that comes in this season's kit. Take a break from that. Spotlight. Okay, back to me. Let's see. Okay. I'm just gonna put this stuff away. So we're gonna go ahead and actually tinker with these kits. During this meetup, there's not a lot of people here or active people. I know, Jessica, you're listening in. We would like to do more of these in the future where we're more interactive and we're kind of like open-ended and just like very casual. Anybody wants to come in. Again, every third Thursday, we're doing this. And we could probably tinker and answer questions and learn along with you. Because even every time I mess with this, I learn something as well. So the way this program works is we're actually like, I know I unboxed this kit for you, but in the future or this season, we plan on having these floating classroom sets where everything is there. We're going to try to have iPads to go with each of these. It kind of works well in groups. So, 2 or above, however many really you feel comfortable with your students. But this is a great group activity, and having the iPad there so that you don't have to bring anything to the table. We're going to try to provide everything with these floating loanable classroom sets. And we're actually doing one that's about 2 weeks, but we're very flexible. We're working on building out the curriculum to be multiple options so that you can do it on a shorter time frame or a longer time frame. The one we're doing next is going to be about a 2-week class in the actual classroom. Yeah, we want to do this statewide. We want to go statewide, but right now most of our work is here in San Antonio. So we want to grow where there's want to be able to sponsor these events or have these events or these workshops and classes put on. We can send this loanable set to a classroom anywhere. Okay, so I am going to go ahead and pull back up this screen here. Okay. So this is a visual of what you just saw, the microbit, and I have coded it to do something fairly simple. It's going to send all the power it has just to run through this from pin 0 to ground pin here. And that's all we're having it do. This is like electrolysis. We're running a current of electricity. This is a very small current. And that's one of the things we're kind of tinkering with it right now, is that how long will it take for this process to happen? Because the more power that you have, the more current, the more energy you're able to utilize, the faster this process will work. But there's a balance. Like, we don't want to waste too much energy. We want to try to see how energy conscious we could be, how much energy we could save by doing it efficiently. So sometimes we like playing in the lower energy realm of using a low amount of electric current, like our envelope kits. They use just a little coin battery basically, and they are able to run the process. So we're currently where we're at with these kits is seeing what the right balance is of how long it takes to run this process of clearing up the water with these kits. So let's see, I'm gonna put that microbit there. And I'm gonna kind of just quickly go with what this code says. So on A, press full power to pin 0, plays the melody, and then it goes as long as you want until you're done. And when you're done, you hit the B button, and it'll play a melody as well. Let's try something different, actually. Let's add something to this. So this is, very basic right now. Let's add, let's see, basic. So this is something like, this is going to show something on the screen. So show string, and it says hello. So you know what? I'm going to put this here, where every time we push the button, it does this, and then it'll say hello. But instead of hello, how about we go on, so that it is turned on. And you know what? Let's do the same down here. So I'm going to duplicate this, drag it here in between these two, and go off, so that you know that you've turned it on and off. So let's test this virtual microbit here. So it goes on. Yeah, I don't know if y'all can hear that sound or not, but it played that melody too. And it should be sending power through here. I don't know why it has a little headphone jack here, but it should just be like, you'll see how it's going to look when we set it up. So it's running. You know what? We're done. We'll hit the B button. Oh, it says off. Oh, it even does lowercase. I didn't even know. That's pretty cool. So yeah, so that's on and off. Super simple. So we are going to connect this and upload it to our microbit. And the way we do that is, let's see, download it. So I'm going to actually plug it in. This will be the first time I've actually done it this way, but why not? I will learn on camera. No pressure. Okay, so I've plugged in. You can see in the other camera that I plugged it in. I will add device. I guess the extension is asking me to add the device, microbit. Okay, we'll see if that works. It's now safe to disconnect. Your files are still uploading, but it's okay to disconnect microbit. Huh? Okay, let's see. Press the pair button. Okay, will appear at the top of your browser. Pair. Selecting that. Selecting that microbit. I'm pairing it. It's thinking. It's connected. Cool. So hit download, and it should be sending it right to this microbit, the code that we just made together. And I'm just going to assume that it did. Oh yeah, there's a little light there. Okay. I'm gonna unplug it. And I haven't done anything. I'm not, it's not set up with the electrodes or anything, but let's just test it out with a battery pack. So I've already put some batteries in here. I'm gonna spotlight this other, let's see. Okay, so I have a battery pack here. Battery's already inside. You plug the power here right next to the USB. And that light, I guess, means that it's got some power. On this light, I guess, is in the code, so it shows up there. So I'm gonna start it by pressing A. On. Cool. So it's running power, but there's nothing connected here. So I'm gonna stop it. Off. There we go. So we coded the microbit together. Now let's put the actual kit together. Let's run this process. We probably won't have time for the whole like coagulation. I'm probably going to cut this video early just because it's not an interactive one. Let's see. Well, somebody tried to join and I didn't see them, but I've been trying to check. Okay, so I am going to go and fill some water in here up to like this little line. There's some lines right here. I'm going to fill it up to that line and I will be right back. Okay. Just under that line, we are going to take our black powder paint. Now, careful with this. Once you open it, you want to dump it in and then throw it in the trash real quick because you don't want the powder paint to really get anywhere. Then you put the lid on top and you shake it. Just get it all shaken up. Next time I need to get a better camera for this other one while I'm filming this. And then just get all that paint just mixed in there really well. Okay. Then take this 3D printed lid, put it on top. You're going to take the alligator clips. You're going to place one on the 0, pin 0, and the ground. Now what we're testing out actually later on, I'm going to be messing with this maybe with some other volunteers, is you can also put on the 3-volt, and I think that changes the amount of power that goes through it. But we're going to really try all these different things to see if we can speed up this process for this year's kit. Then we, after they're connected to the pins, the ground and the O pin, we put it, I'm going to raise this a little bit. There we go. That's a bit better. We put one in one of these slots. And the reason why there's numerous slots is, one, you can actually have multiple of these if you want, or two, it's a way of testing out, like if they're further or closer, if that makes any difference in how fast you can coagulate. There's, like I said, there's a lot of variables to be able to have fun and test out if you can make your kit run purify water faster than other participants, if y'all want to do a challenge. So here's our kit. this is pretty much how it's going to look set up. Let's go ahead and start it. On. So right now it is running power through these electrodes and into the water. And what you can do is if you get a flashlight from your phone or any other flashlight, you can, kind of run it through. And it's a little dark right now, so you might not be able to see it, but you want to look and see if you can see bubbles happening at the electrodes or through the water. And part of this program is we will be checking at continuous intervals to see how this water is affected by this process. And what happens is over time, the pollutants will actually coagulate, like they'll bunch up together and start to separate from the water. They'll become, in some cases, denser than the water. And in some cases, it'll float up to the top because there's oxygen and hydrogen being formed from this electrolysis experiment. So this is what it'll look like after a while of electrocoagulation. You'll see there's a bunch at the bottom and there's a bunch at the top. And then what we can do with this is we can actually filter it out, and you can see how clear it can become after filtering it out. And part of this is checking out how clear you can get it. We use coffee filters. Actually, I don't know why that kit did not have coffee filters. It's supposed to have coffee filters as part of the kit. But you can show as a as a what's a control before you do any of this experiment. You can mix this paint and run it through a coffee filter, and you'll see it catches some of it, but it really doesn't do a big job. But what after coagulation, a lot of those pollutants will clump together and become a lot easier to filter out because they're actually bigger. And the way this process works is when you run a current electricity through electrodes like this, in this case, we're using aluminum, you can actually try different types of metals. Little ions from those metals will go off and in the water look to bond to opposite charged particles. And sometimes they bond to pollutants. And that can happen over and over and over. And these will bond the pollutants to make them be filtered out easier in the future. So that's why it's called electrocoagulation. But to keep it simple, you can also say it's another form of electrolysis because it's the same thing that, chemistry classes do as well. So that's basically it. After, you check out how it does over time. We're not going to have enough time to really get it to this. But then you turn it off. You wait for that fantastic music. Maybe one of your students can make a really cool tune to go with it, and we'll start using that tune. But yeah, that is basically how our kits work. So Jessica says, when we would do this, we'd put one of your videos for them to watch, so they're not just waiting to have some discussions or worksheets. You're right. This is actually a good time when this is running to, I'm gonna switch the video. Let's see. So this is actually a good time when you run the kit to actually be able to talk about things, because it's kind of the boring part. And, you can have it set so that your students check at certain intervals, 5 minutes, 10 minutes, 2 minutes, whatever you'd like. Our kits are going to be coming with the data sheet. The instructions aren't finalized for this, so they aren't in these kits as you saw. But yeah, that's a good time to, like, we've made videos. Like a big part of MakeWater is I'm a filmmaker at heart, and I like the story of what we're doing. And I try to share different vignettes of different water related stories, or even sometimes what the students have done. They can be part of the story because they're part of being a citizen scientist. So there's a lot of ways that you can actually apply this. It's a catalyst for education, as we've seen over the years. For all ages, we have the envelope kits that are kind of for elementary. We have a program that a virtual curriculum that goes with that. These microbit kits are something we're trying out this year. And we also have the advanced codable kits for those students that and we've done it in the past where they just like take it and they run with it. And they've created some amazing sensors for it with laser sensors and light sensors to check the how it gets clearer and clearer over time and take a reading automatically from that. So we're really excited to try out these new microbits and see what the students can do, just because it just seems a lot more intuitive on the way that you code it and how fast you can try something. The only thing I'll say is we're really trying to figure out if it's got enough oomph, enough power. So it's got the like cool coding side, but the power we're still going to be working with that. So we'll see what we can do. But yeah, so that's a basic intro to what we're doing with these microbits for middle schoolers. We're building out a curriculum that we can go more in depth. We're working with a great, wonderful middle school educator who is helping us develop that and pilot testing it with another middle school educator here with his class. We're really excited. So if you're interested, reach out, ryan@makewater.org. Yeah, I think that will conclude this third Thursday meetup. I will see y'all every third Thursday as long as it's not some sort of like vacation or event or something. I don't know. We're gonna always try to make it third Thursday of every month. So take care. Catch y'all at the next one. Thanks, Jessica, for stopping in. See y'all later.